Okay, guys, so I'm going to go over this mini lesson today, and this is what we will be covering in class today. This one's going to seem, I will be honest with y'all, some of you are probably really comfortable with fractions, and so you're going to look at this and be like, are you kidding me? We're about to go into rational fractions, and so that's why we're going to go over the properties of when you add, subtract, multiply, and divide fractions, just as a reminder, so that way once we kind of throw letters in there, we don't forget what our rules are as far as fractions go. Okay. All right. So as a reminder, whenever you add fractions, okay, you have to make sure that they have the same denominator. All right. Let me make this a little smaller. Sorry. Okay. So same denominator. So when they have the same denominator, you're going to keep the denominator and then add the top two. Okay, so that would just be 5/8. Now, one thing that you would do at the end, if needed, is you would simplify the fraction. But the fraction 5/8, it can't simplify. It's already in simplest form, and so we would leave it as that, okay? All right, so then we move on to our next fraction. And we have 1/2 plus 2/3. And we notice that they do not have the same denominator. So we're going to have to find the LCD, least common denominator here. And so the number that is in common between 2 and 6, or the multiple that's in, or I'm sorry, back up. The number that is in common between 2 and 3, the multiple there would be 6. So I'm going to make these fractions have a denominator of 6, okay? Because what I can do is I'm going to take 2, use a different color, and I'm going to times it by 3 to give me 6. So then I would take 1 times 3. Well, 1 times 3 gives me 3. And then moving on to my 2/3 fraction, I'm going to multiply 3 by 2 to give me 6. So that means I'm going to multiply the top by 2. And so 2 times 2 would give you 4. Okay, so now that you have common denominators, same thing that we just did on the last one, you would just keep the denominator the same and do 3 plus 4 to give you 7. Okay, and you can go ahead and leave it in as an improper fraction. That's fine. All right. Okay, so moving on to the next fraction here. We have 3/4 plus 16/8. Don't worry about, go ahead and simplifying the fraction. Don't worry about all that. Okay, for the purpose of this lesson, we're just simply adding fractions, okay? So I can go ahead and multiply 4 by 2 to give me 8, and that will make me have a common denominator already. I'm not going to have to multiply the second fraction by anything because I'm already going to have a common denominator. Okay, so 4 times 2 gives me 8. So what I do to the bottom, I'm going to do to the top. So 3 times 2 is going to give me 6. Okay, so now I have 6/8 plus 16/8. And whenever I add those together, we get 22/8. And that would be our fraction there. Okay, okay, so the general process over here. The first thing, we're going to find a common denominator. Okay, if they already have a common denominator, you get to skip this step. But make sure they have a common denominator. The second step is going to be to multiply by the needed value to create fractions with the common denominator. Let's see if I can put fractions. And I'm going to put LCD, so the least common denominator there, okay? All right. And so then the next step would be to add numerators only. Okay, you do not add your denominators, you only add your numerators. And then the last step, if needed, is you're going to simplify if possible. Okay? All right, so let's go over here to our subtracting. So subtracting is much like adding. You have to have the same denominator. Okay? Okay, you've got to have the same denominator. So on this first example, we actually already have the same denominator. So when you do that, you just take your top, your 5. Talking about our 5 right here. We're going to take our 5 and we're going to take subtract 4. Sorry, words weren't coming. So 5 minus 4 gives me 1. And then I keep my denominator. Okay, 1 over 16. Okay. All right, moving over here to our second example, we have 17 over 12 minus 2 over 3. Well, they don't have common denominator, but they don't have common denominators right now, but I know that 3 can go into 12. So I can multiply 3 by 4 to give me a 12, and then I will have common denominators, okay? Excuse me. So I have 17 over 12 minus something over 12. So I multiplied the bottom by 4, so I'm going to multiply the top by 4. So 2 times 4 gives me 8. And 17 minus 17 minus 8 is 9. So I get 9 over 12. Now, we didn't do it on the addition. We could have, but we just didn't. But now we're going to need to simplify this. Okay, so 9 and 12 can both be divided by 3. So I'm going to divide by 3. So 9 divided by 3 gives me 3. 12 divided by 3 gives me 4. Okay, so that would be our simplest form here. Okay, all right, so now on this one, we have 8 over 9 minus 1/2. And 2 can't go into 9, so we can't make that easy. Okay, so we need to find an LCD. So what number can go into 9, or what multiple do 9 and 2 have in common? Well, that number would be 18. And I will tell you kind of a trick, if you will, that you may already know. If you aren't very good at your math facts, what you can do to find a least common denominator is just take your numerator or your denominator times your denominator, okay? You will probably have to simplify eventually, but that will always work as well, okay? Okay, so if I'm trying to get an 18 on the bottom, I would take 9 times 2. To give me 18, okay? And again, what I do to the bottom, I have to do to the top. So 8 times 2 gives me 16. Okay, so then I move over here to my 2. I needed the 18 to be on the bottom. So in order to get an 18, I would multiply by 9. So then 1 times 9 gives me 9. Okay, and then again, we're just going to simplify, or go ahead and do our arithmetic here. So 16 minus 9 gives me 7. And then I'll leave my denominator the same. And 7 over 18 cannot be reduced. Okay? All right, so the general process, I'm going to save y'all some writing as far as what she put on her answer key. But just know that it's going to be the same as adding. Okay, it's going to be the exact same process. I don't feel that you need to write it multiple times, the process. So we're just going to put same as adding. Okay? All right. Now, once we get to multiplying is actually very, very simple. Super simple. Okay, so when we multiply fractions, we multiply straight across. So we're going to do 1 times 2 to give me 2. 6 times 3 to give me 18. Okay, and then I would need to simplify from here. So the first thing I notice is that 18 and 2 are both even. So I'm going to divide by 2. And 2 divided by 2 gives me a 1, and 18 divided by 2 gives me a 9, and that cannot be simplified any further. Okay? All right, I'm going to do this next one 2 different ways. She shows 2 different ways. Just because you may do one or the other, I just want to make sure you know that, yes, you are correct. All right, so again, just like I said a while ago, when we multiply fractions, we multiply straight across. So 7 times 9 gives us 63. And 18 times 21 gives us 378. Okay? Now, obviously, this is a really big fraction. Both the top and the bottom are big numbers, so we're going to need to reduce this. Okay? And so one thing, I know 9 will go into 63, obviously. Let's see. 378 divided by 9. Okay, that gives me 42. So I'm going to go ahead and reduce it by 9. Okay, so 63 divided by 9 gives me 7. 378 divided by 9 gives me 42. Okay, well, I know my factors of 7, and I know that 7 and 42 can both be divided by 7. So I'm going to go ahead and reduce it one more time by 7. So 7 divided by 7 gives me 1. 42 divided by 7 gives me 6. Okay, so this would reduce to 1 over 6. Now, you could have, and this might be the way that some of you like to do it, and that's fine. You could have done it this way. So we have 7 over 18 times 9 over 21. So what some people like to do, because it cancels or prevents you from having to do as much factoring or simplifying at the end, is that they cross cancel. So 9 and 18 are both divisible by 9. So 9 is divisible by 9 once, 18 is divisible by 9 twice. Okay? Same thing here with my 7 and 21. I'll use a different color. 7 and 21 are both divisible by 7, so I'm going to divide by 7. 7 divided by 7 is 1. 21 divided by 7 is 3. And then from here, I'm going to still do my same multiplication of fractions properties where I'm going to just multiply straight across. So 1 times 1 gives us 1. 2 times 3 gives us 6. And we will not have to simplify on this one, okay? So either way that you prefer to do it is correct. As you see, it gives you the same answer. So again, it doesn't matter which way you do it, okay? I'm going to do this last example for multiplication the same way I did the last one, excuse me, where I'm going to do it both ways. So again, when I multiply fractions, I'm going to multiply straight across. So 12 times 4 gives you 48. 16 times 5 gives you 80. Okay? And I'm going to reduce this. So just thinking off the top of my head, I think 48 can be divisible by 16. Yeah, we're going to divide by 16. Okay? So 48 divided by 16 gives me 3. 80 divided by 15 gives me 5. I meant 80 divided by 16, excuse me. Okay? All right, then I'm going to bring this other one down here, and I'm just going to cancel. Just so you know, you do not have to do it both ways. I'm just doing it in case somebody wants to do it that way. So if you look at your diagonals here, 4 and 5, those obviously there's nothing that can cancel there. However, 12 and 16 can. So 12 and 16 are both divisible by 4. So I'm going to take 12 and I'm going to divide it by 4 and give me 3. 16 divided by 4 gives me 4. Okay? So now, again, I'm just going to multiply straight across. So 3 times 4 gives me 12. 5 times 4 gives me 20. Okay? So as you can see in this example, just because you cross-cancel some of them does not mean that it's going to give it to you in simplest form. So I need to divide my numerator and my denominator here. All right? Now, one thing I know is that 12 can be divisible by 2. It's also divisible by 3, but 20 is not. And it's also divisible by 4. Okay, so 4 goes into both 12 and 20, so I'm going to divide by 4 on the top and the bottom. So 12 divided by 12 divided by 4 gives me 3. 20 divided by 4 gives me 5. Okay, so again, I got the same answer there. Okay. All right, and then the general process, this one doesn't have as many steps. There's only 2. The first thing we're going to do is we're going to multiply straight across. I'm not putting that you can cross cancel, but just know that you can. We're going to multiply straight across. So what that means is you're going to take numerator times numerator, and then denominator times denominator. Okay? And then the last step, which would be with all of these, is just going to be simplify if needed. Okay? All right, if you need to pause that for a minute, go right ahead. Okay, and then dividing. So whenever we divide fractions, I use the kind of, I don't know, the key, I guess you could say phrase, if you will. I say keep, or KCF, keep, change, flip. Okay, and so I'm going to write that up here just for you. Change. If you have a different lingo, that's fine. Flip. Okay, so what that means is we're going to keep the first fraction, change from division to multiplication, and then flip the last fraction. Okay, so when I keep 1 over 6, I change from division to multiplication, and I'm going to flip from 2 over 5, I'm going to flip it to 5 over 2. Okay. Now, 1 times 5 gives me 5, 6 times 2 gives me 12, and 5 over 12 cannot be reduced. Okay? All right, moving right along. Again, we're going to do KCF. So keep the first fraction, multiply, change the multiplication, and then flip the second fraction. So 3 times 2 gives me 6. 10 times 1 gives me 10. Now I need to reduce this. So I know that 6 and 10 are both divisible by 2. So I'm going to divide by 2. 6 divided by 2 gives me 3. 10 divided by 2 gives me 5. And that would be our reduced fraction there. Okay. Excuse me. And so now on the last one, again, we're going to do KCF. So we're going to do 20 divided by 9 times 18 over 30. Now, one thing I didn't do on the last one that I could have, but it's up to you if you do it or not, sorry, is we can do cross cancel. So on this one, like 20 and 30 can both be divisible by 10. So I'm going to divide them both by 10. And then 9 and 18 can both be divided by 9. So I'm going to divide it by 9. Like I'm just going to cross cancel that, okay? All right, so 2 times 2 will give you 4. And 3 times 1 gives you 3. And then that can't be reduced. Okay? All right, so general process here. First step, how small is that? Okay, that's fine. First step is we're going to keep the first fraction. Second step, I will tell you there are technically 5 steps here, just so you know to not write too big, okay? But we're going to change division to multiplication. Okay, excuse me. Third step is to flip the last fraction. So think about reciprocal. Fourth, multiply. Straight across. And then fifth is going to be simplify if possible. Okay. All right, so now this was, like I said, this is just the mini lesson that honestly was optional, but I felt like it was probably a good refresher just as a refresher of fraction rules. And so we will be covering this today in class, and then we'll also be going and starting some of our 9.1 notes. So I'm going to stop the video here, and then I'm going to pull up 9.1 and cover what we're going to cover today in class 2. Okay, all right.